Welcome to Science of Academy. Now today we want to look at the chemistry question. It's a past question, specifically jam past question. Now let me take the reading of the question. The question goes this way. According to Lechitlaire's principle, increasing the pressure of the reaction below, this is the reaction, now will shift the equilibrium A to the left, B to the right, C, it will not change, D, the reaction will stop. Now let's identify what kind of reaction we have. Now in chemistry we have series of reactions, from combustion reaction to other types of reaction. Now let's look at this particular question and identify what type of reaction. Now taking a look at this chemical equation that brings about a reaction, we can see something is obvious. Now look at this arrow. This arrow is pointing to the right and equally to the left. Now anytime you see a chemical equation representing a reaction, now showing two arrows forward and backward, just have it at the back of your mind that it is a reversible reaction. And most reversible reactions are reaction in equilibrium. Now we are asking a question, and this question is in consonance to a principle known as Lechitlaire's principle. Now Lechitlaire's principle is just a simple principle, a system used to attain equilibrium. Take note, equilibrium is a state of balance where there is no need change between the reactant and the product. Of course, if you are not naive to chemistry, some of these terms I'm using should be relevant to you. So Lechitlaire's principle is one of the principles that conforms to equilibrium theory, stating that anytime there is a disorder in a chemical equation, now the system is going to automatically try to balance the effect that caused the change. Now let's look at this question and nail down it directly. So let's look at the reaction. Now the reaction has represented something that is not really obvious to us, but I want to make it obvious to you. Now look at the number of moles of nitrogen. Now you can see it's 1. When nothing is written, it's invariably 1. Now look at this one is 3. So we can say that the reactant, the total mole of the reactant is 4. So we could say 4 mole. Now let's look at the total number of moles on the product side. So if you look at the total number of moles, you can see it's 2. So I can put here 2 moles. Now, without taking us too far, I want to just drop something very simple. Now, there are different factors that could affect a system in equilibrium. It ranges from temperature, it ranges to concentration, also include pressure. So we want to look at pressure. Now take note, anytime we're talking about pressure in chemical system in equilibrium, we have to include the volume. So, but in this aspect of the question, I'm just going to narrow moles, pressure and mole. Now it is certain that it is a fact that anytime pressure affects the system in equilibrium, now to favor the reaction, or to let's say to make the equilibrium move to the right, because when we say we'll shift to the equilibrium to what? To the left means it's not favoring it, to the right means it's actually favoring it. So when pressure is imposed on a system, one thing is certain. Now if there's an increase in pressure, now the pressure will favor, the change will favor the side of the equation that has lower number of moles. So if we say a pressure is imposed on this system, now we have 4 moles here, 2 moles here. Now the side is going to favor is the side with the fewer moles, which is clearly 2 moles, which is the right hand side of the equation. So you can see that if we impose pressure on this system now, what is going to happen is that the equilibrium will shift to the what? To the right, because we have fewer number of moles. 2 moles is less compared to 4 moles. So pressure imposed on a system will be favored from the side that has a lower number of moles. So from the question, it is obvious that 2 moles is on the right hand side of the equation. So increasing the pressure of the reaction will shift the equilibrium to the what? Right. Shifting the equilibrium to the right means the reaction will proceed favorably without any hindrance. So this is the size of what we have. We've been able to look at Lechitlaire's principle. We've been able to identify what kind of reaction is this. And ultimately, we've been able to give answer to this question. It was a nice time actually answering this question with you. I'm looking forward to having you sit and watch more of our intriguing videos like this. See you in other videos. Bye.
Every question has a light. Every answer shines so bright. Step by step we'll learn the way, growing stronger every day. Dreams begin with one small start. Knowledge builds a faithful heart. Together we can reach the sky.